Okay, so we'll pass on to next problem. So here where both ends are fixed, you can see here it is fixed at A and C. In between we are having one support, intermediate support. Okay. So as I told you already, whenever you get fixed support according to Clapeyron's, we have to introduce the imaginary support of imaginary span. Okay, so on either side, I have introduced imaginary length L naught in the left hand side and L naught dash on the right hand side. Okay, now the spans are OAAB, you will get one equation, and ABBC, you will get another equation, then BC, CO dash, another equation. Now you see here span OAAB. M naught L naught plus 2MA into L naught plus L1 plus MB into L1 is equal to 6A naught X naught bar by L naught plus 6A1 X1 bar by L1. L naught 0 and this M naught L naught 0 and 6A naught X naught bar by L naught 0 because it's an imaginary support and M naught is 0 since imaginary. Okay, and then ABBC MAL1 plus 2MB into L1 plus L2 plus MC into L2 is equal to 6A1 X1 bar by L1 plus 6A2 X2 bar by L2. Okay, where we have to calculate MA, MB, MC. Okay, here no zeros. Okay, no zero bending moments because we have simply, fixed supports as well as intermediate support. Then span BCCO dash MB into L2 plus 2MC L2 plus L naught dash plus M naught dash L naught dash is equal to 6A2 X2 bar by L2 plus 6A naught dash X naught dash bar divided by L naught dash bar. Okay, M naught dash is 0, imaginary part. Again, 6A naught dash X naught dash bar by L naught dash is 0 and L naught dash is also 0. Okay, it's an imaginary part. Now we have to draw the mu diagram by considering the individual spans as individual simply supported beams. Okay, now you can see here this is the mu diagram due to vertical loads. Okay, bending moment at mid of span AB is WL square by 8 because it's UDL. W is 2, L is 6 by 6 square by 8, so 9 kilonewton meter. Now AB on AB, WL square by 8 is the maximum bending moment at mid of AB. Then at D, bending moment at D, here the load is a bit symmetric on the span BC. Okay, WL by 4, WL by 4. In earlier problems, we have seen the span is subjected to an eccentric point load. Now you can see here the load is acting exactly at the middle. So WL by 4 is the formula. So W is 12, 12 into 6 by 4, that is 18. The nature of the bending moment diagram is a straight line, that's a triangle. So draw the triangle. Now mu diagram is over. Then A1 X1 bar, how will you calculate for this? Parabola A1 area of the bending moment diagram 2 by 3 into 6 into 9. 2 by 3, 6 into 9. X1 bar is CG distance from A. Okay, so 6 divided by 2 is 3. So A1 X1 bar is 108. So if you substitute this in the Clapeyron's equation, that is in this equation span OAAB, okay, you get 12A plus 6MB is equal to 108 as equation 1, as equation number 1. Okay, because 6 A1 X1 bar by L1, 6 L1 is also 6, 6 will get cancelled, so you'll get 108 as it is. Let it be equation 1. Then similarly ABBC again, ABBC L1 substitute here this length and L2 this length. Okay, here MA, MB, MC, all the three unknowns. So A1 X1 bar again for this same area, same length. So A1 X1 bar will be same whatever you have taken for this OAAB. It is applicable for ABBC because UDL is same, length is same. Okay, and A2 X2 bar here, A2 X2 bar. Okay, for ABBC, A2 X2 bar, A2 is area of the bending moment diagram, X2 bar is CZ distance from C. Okay, A2 area off into 3 into 18, off into 3 into 18, and 2 by 3 of 3 plus off into 3 into 18, and CG is here for this triangle, 3 plus 1 by 3 of 3. This is the CG distance. So A2 X2 bar is 162. So substitute in this, you get 6 MA plus 24 MB plus 6 MC is equal to 270, which is nothing but equation 2. Now we should consider BC CO dash. For BC CO dash, this is the equation. Okay, this is the equation. Okay, so now bring the equation here. So 12 MA. Okay, so substitute L1 here. and L1 also is equal to 6A1 x1 bar divided by, so not this equation, sorry. So MB into L2 plus 2MC into L2 plus M naught dash L naught dash is equal to 6A2 x2 bar divided by L2. Okay. So this term is 0 as it is imaginary part. Okay. And L2 you know the value. Okay. L2 you know the value, substitute here. X2 bar, A2 x2 bar by L2. 6A2 x2 bar by L2. A2 x2 bar we have calculated here. 6 will get cancelled. So you get as it is 162. Let it be equation 3. So equation 1, equation 2, equation 3, solve the three equations and get MA, MB, MC. So now we have got the values MA, MB, MC. Now you try to complete the mu dash diagram. Okay, MA 5.25 and MB 7.5 and MC is 9.75 kilonewton meter. So complete your mu dash diagram. Now resultant bending moment diagram is over. Now with this MA, MB, MC, we have to find the unknown support reactions RA, RB, RC. Now indicate the directions MA, MB, again MB for span BC, then MC. Okay. Now we write down the bending moment equation. Okay. Excuse me. For AB, B as a reference point, consider all the forces and moments to the left side of support B. RA into 6 minus 2 into 6 into 3 plus MB clockwise minus MA anti-clockwise. Find out the RA. Then BC, right side anti-clockwise positive, clockwise negative. So RC into 6, 12 into 3 negative clockwise. Okay, then MC minus MB plus. So find out RC 6.375 kilonewton. Then after calculating RA/RC, write down this vertical equilibrium equation. Sigma Fi is equal to 0. RA plus RB plus RC minus 2 into 6 minus 12. Substitute RA/RC, get the value of RB, 12 kilonewton. So once RA, RB, RC are obtained, now you plot the shear force diagram. RA 5.625 positive upward, 5.625. Then at B, 5.625 minus 6 into 2 will be minus 6.375. So minus 6.375 at B plus RB. RB is 12. So you will get plus 5.625. Between B and D, no loads. So 5.625 shear force remains constant. Once I reach D, 12 is acting downward minus. So 5.625 minus 12 will be minus 6.375. Between DC, no loads, shear force remains constant, minus 6.375. Once I reach the point C, at C, RC is acting upward. So minus 6.375 plus 6.375 is 0. Complete the diagram. Now the shear force diagram is completed. Thank you.